Thank you. Thank you. Nice to see so many of you still here, even though it's a little bit late. But yeah, Xcode source editor extensions for fun and profit. Xcode and fun in the same sentence, like what is this guy talking about? But we'll find out. First of all, a few words about myself. My name is Andrii, and I work at Nextory. It's a book app where you can read ebooks and listen to audiobooks. Yay! I have been doing iOS since 2015, but also throughout my career, I have done a few other things like QA and Android and React Native. I have some backend experience. And there was a great opportunity to try different programming languages, different tools. So yeah, really enjoyed that. Of all the great tools, of all the great tools, we are going to focus on IDEs today. Xcode, as you said, is the one we know and love. Android Studio is another one you may have used. There are a few other ones. Could you raise your hand, those of you who have used other IDEs than Xcode? Yeah, that's quite a few people, most of the people. That's nice. And is there anyone here who has never used an IDE?
No, it's impossible.
That's good. That's good. Anyway, let's take a step back and reflect why we use IDEs. What makes them so good? What are the things we do a lot as developers? We read a lot of code. So anything that helps with that is a great boost for productivity. It's things like code highlighting or folding or go to symbol or find all usages. We also do a lot of code editing and refactoring features like renaming or extract to variable or change method signature are great help for that. Ultimately, it's all about achieving the state of flow, where you're programming at the speed of light and you feel super productive. It's a great feeling. I'm sure everyone loves it. But Xcode maybe is not much help with that. I really hope we don't have anyone from the Xcode team here today. No? No? Okay, good.
It's okay, we're a majority. So.
Yeah. But yeah, Xcode lacks a lot of features that other IDEs have, and I really felt this gap around 3 years ago. Before that, I was using AppCode full-time, but AppCode was discontinued, so I had to switch back to using Xcode basically full-time, and I felt like my productivity dropped in half, basically overnight. Things that used to be like a simple 10-second operation suddenly took 10 minutes of search and replace, build, fix errors, rinse and repeat. I'm sure this sounds familiar to you. With time, of course, I adapted, but I couldn't get rid of this nagging feeling that things could have been different. And one of the features from AppCode that I missed a lot was expand shrink selection. This is a feature that can change the select code based on the knowledge of the structure. What do we mean by structure? For example, we know that if statement consists of keywords, condition, if branch, else branch. And why is it such a powerful feature? Because when we edit code, we operate on these pieces, on these components. We may want to select a piece of code and copy it, or move it somewhere else, or delete it. And of course, you can find these pieces mentally, like in your head. You can run this little compiler in your head, but it's not very fast. It's not very convenient. What's faster and more convenient is to offload this task to an actual compiler. And because, yeah, code gets complicated Shout out to those of you who love one-liners. But yeah, this feature can be a great help. To give you a better impression, let's see how it works in Android Studio. So we have selection, we press expand, and we progressively select bigger chunks of code, and we shrink, we go back. So if we want to build this for Xcode, what do? Well, those of you who have been around long enough remember that Xcode used to have plugins. With plugins, you could do some really cool things like add menu items to trigger Cocoaheads directly from Xcode, or colorize console output, making it so much easier to read. But building plugins required funky stuff like swizzling. It ran in the same process as Xcode, so you could see how this is pretty dangerous. So in 2016, Apple said, no more, and they basically killed plugins overnight. Kind of understandable, was a sad day. Instead, they gave us source editor extensions. Unlike plugins, they ran in separate process, they didn't require swizzling, much more secure and reliable. But as you may have guessed from the name, they only could work with source editor, which is the part of Xcode where you see the code, where you change the code. So yeah, kind of like difficult to do cool stuff that we used to do before, but yeah, that's what it was. But before we dismiss extensions altogether, let's have a look at what they are, what they can do. When you create a source editor extension in Xcode, you get this class, which is kind of like app delegate that we have in our apps. Similar idea. In this delegate, you define your command. Each command has like the name of the class that implements it, a unique identifier, and the name that user sees in Xcode. So far, so good. Then we also have an entry point, like a method that executes once when our extension is initialized. Now let's have a look at how a command is implemented. Again, we have a class, and this class has a single method. That's it. Perform, it's supposed to sync await. Very nice. And when Xcode calls this method for us, when user triggers the command, we receive this invocation object. And in it, we have things like source code and the type of the source code. It could be Swift file or Objective-C. It could be something totally different. And also things like tab size for 8 or 2, or tab character. And we also receive the current set of selections. So yeah, we do some processing, do some work, transform this code. For example, we could take selected lines and add the 2 slashes in front of each of them. And that's how we comment things out in Swift. And once we are done, we just ask Xcode to apply these changes by updating this invocation object. So yeah, seems pretty simple, I hope. So back to our goal, implementing expand and shrink selection. How do we do that for Swift code? Let's say we have this very simple, tiny program. What do we do with it? And we can start, so we said that we rely on the knowledge of the structure of this code. So how do we get structure from this code? We can use a library that's called Swift Syntax. Those of you who know about macros, maybe even develop macros, know about it. I won't go into details how you use it. There are a lot of great talks about this. But let's say that we have built the syntax tree of this code, and that's what it looks like. for this simple program. It's a little bit simplified, not exactly what you get, but yeah. And so yeah, we can see we have our if expression with condition, with code block for if and for else. And more importantly for us, we also get locations. You see these numbers next to each node. That's the start and the end of this node, offset from the start of the file. So yeah, so far, that's what we need. Now, what do we do with this? Let's say that user placed cursor next to the plus sign in this code and pressed the expand command. So we need to find the scope, the smallest, the closest scope that contains this selection. We start from the root of this tree, the source file. We check the bounds. It contains our selection, so we check the children. Not a match, not a match. This one is a match, so we go one level deeper again. And eventually we figure out that this is the node, this is our scope that we're interested in. So this will be our next selection. So we ask Xcode to apply it. So that's what we need to do. That's basically it. Now let's see a little demo. This is a screen recording from Xcode. Not doing live coding today, sorry. But yeah, we have our cursor, expand, 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 and so on, and so on. And now we shrink. So, yeah, there we go. That's a win. Thank you.
We're back to where we were 10 years ago.
I know, right? So with that, we have more precise selection faster because we offload parsing of the code to the actual compiler. And this helps us free up our mental bandwidth for other, more interesting things. And this may seem like a small win, but ask yourself how many times in a day you do this. And these small wins, they really add up. Now let's look at a totally different area, and that's code formatters, also known as prettifiers. You know, the decades-long debate whether to use spaces or tabs, or how many of them to use to format your code. I'm sure you have had this argument with your colleagues many times and you have spent many hours arguing over that. And that's a problem because we want to argue over productive things. So yeah, it's good to apply code formatters in your project. What are the options we have for Swift code? We have the official Swift format with dash. That's developed by the Swift team. And we also have Swift format without the dash. That's the unofficial one, developed by the iOS community. Also a very mature tool with tons of configurability, a great one. I won't, there are reasons to pick one or the other. I won't go into those reasons, but that's, in our team, we ended up adopting the second one, the unofficial one. As I said, it's a great tool, plenty of configurability. But a pain point for us was integration with Xcode. We had it integrated as a build phase, and that's not great because it's slow. You have to build the project every time you want to format a file. But also, this ends up modifying the file outside Xcode. So any undo history you had in Xcode, it gets erased. So that's not great. And this project has its own source editor extension. And yeah, It makes the process much faster, but it has a problem. It has a totally separate config that you have to keep up to date. And if you have to switch to different projects with different formatting rules, you need to remember to switch the config manually. It's quite cumbersome. And yeah, so what can we do about that? We need to find a way to read the config that we have in the project. And how do we do that? We need to know which project we have opened in Xcode and where it is located. The problem is that with source editor extensions, you don't have access to anything at all outside the source editor. So like only the source code that you're editing. You don't know what the project is, where it is located, which files it contains. So it's a problem, unless we use Accessibility API. Yes. The idea is to listen to notification center notifications, where we get information which app is currently in the foreground. So that's great. And once we detect that user switches to Xcode, we can start to listening to updates of the focused window and focused UI element. And turns out it's a great way to actually figure out what's opened in Xcode. And I won't go into details how you do that. That deserves a talk of its own. There's just one little problem. We need to get permissions. And it's difficult to do directly in source editor extensions because Xcode gives us only 1 to 2 seconds before it shows a scary banner. Oh, this extension, this command is taking too long. You can cancel it, which is not what we want. So we obviously cannot trigger this dialog directly. So what do we do? Well, we have the host application. If you ever worked with share extensions on iOS, you know that they come embedded in your app. They cannot be distributed separately. And this is the same with source editor extensions. You have the host app. And what's great about the host app is that it runs continuously in background. It can show UI. You can have like a menu bar item. You can show windows. You can run things continuously like Accessibility API observations. So the only caveat is that it runs in a separate process. But there's a way around that. We can use inter-process communication. Fun thing to learn. Very much recommended. So we can ask the host app to request permissions for us and run Accessibility API observations. So yeah, maybe you're already starting to see like how we can put things together, but let's have a walkthrough. So when our user triggers the format command in Xcode, Xcode calls our source editor extension and gives it the source code. Our extension talks with the host app. The host app can run Swift format with the right configuration, with the right project, which is exactly what we need. Then it gets the formatted code and returns it back to our extension. And our extension can ask Xcode to then apply this formatted code. And let's see if this works. We have this messy code that is in desperate need of formatting. We press the button. Voila. And yeah, that's our code formatted with the right config, with the right settings, picked up automatically when you switch the project. So yeah, it's a great addition. It was a great way to solve a pain point for us. And best of all, it integrates nicely with the undo stack in Xcode. So yeah, if you have important things in undo stack, you will still have them. So yeah. Yeah, that's another great feature we built. What else can we do? We can run other commands in the project folder, maybe agents or some other tools and automations like SwiftLint. Accessibility API also lets us track screen coordinates, like where on the screen is Xcode window, how large it is, and same for the active editor and for selections. So we could display UI on top of Xcode. And for example, we could display a menu with refactoring actions that are appropriate for the currently selected code in Xcode. So that could be pretty nice. We could also manipulate Xcode UI directly. One thing I tried is scrolling the editor, but unfortunately it's not very reliable, but yeah, maybe I just haven't found a way to do it. So yeah, there's a lot of potential for future exploration. But in the meantime, let's take a look back at what we learned today. We learned that Xcode source editor extensions are quite straightforward and easy to set up. And for Swift code, there's a great tool, great library, Swift Syntax, that's easy to set up and use, and it's very performant also. And we also learned that if we run into limitations of source editor extensions, we can use Accessibility API to break out of the sandbox. And yeah, we can use help from the host application to be able to use Accessibility API. And yeah, we also learned that it can be a lot of fun to play with source editor extensions, and we can build actual useful features that make our life easier. So yeah, I would really encourage you to play with source editor extensions. And if you decide to do it, here are a few useful resources. There's an old wwdc talk from 2016. It's not available on the Apple website, but you can still find it online. There's a great talk, Swift Syntax for Good and Evil, that goes into detail how to use Swift syntax, not only for parsing, but also for rewriting code. So you remember we talked about those refactoring features, and that would be a great way to implement those. There's a starter, getting started guide on the Apple website. And last but not least, GitHub has a source editor extension for Xcode that integrates Copilot AI. Yes, and with those limited tools that we saw today, the things that they managed to achieve are seriously impressive. So even if you don't end up using it or maybe building your extension, it's just a very interesting tool in and of itself. So yeah, that was my presentation. But before we wrap up, everything you saw today and a few more features are available in this source editor extension that I have built. It's available to download today. You can use it for free. So yeah, do try it out. And if you have feedback, write me a message, or you can just go to GitHub and open an issue. So there you go. Thank you. Yes?
Profit.
Profit.
It's for free, no?
Well, profit in different ways.
Experience.
Yes, exactly. Thank you.
Money.
Yes. Any other questions?
Okay.